Okay, the last part of your chapter 5 is a little bit conceptual and theoretical, a little bit difficult to understand. So try to follow as much as you can. Okay, if you read the title, they say the vector parallel to the line of intersection of two planes. Okay, I'm trying to find a vector that's parallel to the line of intersection of two planes. So if you look at this diagram here, okay, this is the line that is your intersection of the two planes. So focus on this line as well as this normal vector. This is normal vector of the first plane. Is this normal vector perpendicular to the line L? Okay, it is perpendicular to the line L. Focus on the normal vector of the other plane. This normal vector is also perpendicular to the line L. So this line L is concurrently perpendicular to two other vectors. Okay, line L is perpendicular to the normal vector of the first plane. Line L is perpendicular to your normal vector of the other plane. And since, if we were to go back to the definition, A cross B produces a vector that is concurrently perpendicular to two other vectors at the same time. So if I were to do a cross product of the two normal vector, okay, do a cross product of the two normal vector, I'll be able to get a vector that is parallel to line L. Okay, and that is your theory behind this. So one numerical example to run you through this theory. So I have two planes given in Cartesian equation. Okay, the question says find a vector that is parallel to the line of intersection of the two planes. So find for me the normal vector of the two planes. So this Cartesian form, switch into r dot m form is 2a3 is equals to 1. This switch into r dot m form is r dot minus 1 to 1 equals to 2. So take the two normal vector. Okay, these are the two normal vector of the plane. What to do next? Activate your cross product. Once you activate your cross product, this is the result. So the vector that is parallel to the line of intersection comes from the cross product of your two normal vector. Okay, and with that, we have come to the end of this chapter. So what you learn in your chapter 4 is that we introduce to your equations of your lines and planes. Okay, and planes, the different forms. You have your vector equation of the line, the Cartesian equation of the line. For planes, you have the vector equation of the plane, you have the Cartesian equation of the plane, you also have the r dot n equation of the plane. And in chapter 5, we deal mainly with intersection. Okay, intersection of your line and line, intersection of your line and plane, intersection of your plane and plane. Okay, but even though we are intersecting different things, the root or underlying theory behind intersection is to equate. Find your ways to equate the two lines or the line and plane or the plane and plane together. And then if you run through your examples, okay, the methods are rather standard. So please remember fundamental, equate. Then please know or learn from different examples how do you actually equate to find the intersection of these different scenarios. Okay, and that is all for your chapter 5.